Okay, so in the final section, we're going to use what we've learned to try and apply it to some real life situations. So we've got this region here shaded in yellow, and we want to rotate that around the y-axis to get the shape of a barrel of a pen. It's a bit of a weird shape because if you imagine rotating that around the y-axis, your pen would have a completely flat top to it. So I don't know whether they imagine screwing on perhaps the mechanism for the top of the pen to make it click. But if you imagine it, the tip of the pen is going to be at the top here. So we're asked to suggest a suitable value of k, and obviously k is going to give you the y-intercept of this curve. So it's basically going to give you the height. And the units on the axes are 1 centimetre. So the pen barrel is going to be k centimetres long. So obviously you're not going to get a question like this in the exam really, where you're asked to estimate a value of k. Let's just go with 10, because that's what the textbook does, which seems like a reasonable length for the pen. So from now on, let's just say k equals 10, and that's centimetres really. So we want to rotate this around the y-axis, and I guess if you find the fact that it's kind of like there's a region on both sides of the y-axis, this is equivalent to kind of thinking about, well, we're just going to take this portion of the curve here, and we're going to rotate just this red region, which I'm shading in here, around the y-axis, okay? And you'll get that 3D solid. So our formula that we're going to use, we've got to be really careful. We're rotating around the y-axis now. So the formula for the volume is going to be integral of pi x squared dy. And because it's dy, we want y limits, which is right. We want to start on the y-axis at y equals 0. And we want to go up to this point, which is where our region stops on the y-axis, which is y equals k. But remember, k is equal to 10. So that's that y-intercept there. Remember, if you ever forget about that formula, just think we're splitting this shape up into cylinders. So we're drawing a cylinder in like that. And the radius of each cylinder is going to be the x coordinate at a given point. And we're stacking up lots of these cylinders, which is why we've got y limits. We're going to start stacking up the cylinders at y equals 0, and we're going to stack them all the way up to y equals 10. And we're going to add up the volume of each of those cylinders using the integral. So in order to use this formula, we need to get it in terms of y. So we need to replace x squared with something in terms of y. I'm going to take the pi outside of the integral. If we rearrange the formula, we get that x squared is equal to k minus y over 100. But remember, k is equal to 10. So 10 minus y over 100. So if we work out this integral, we're going to have, we've already squared x, so don't square it again. We've already got x squared. So we're just going to sub that straight in, 10 minus y over 100 dy. And our limits are 0 up to 10. So we need to try and integrate this. I'm going to take the 1 over 100 outside of the integral. So we've just got 10 minus y dy. And then we can integrate it. So we're going to have 10y. Remember, we're doing it with respect to y, which is why we've got everything in terms of y on the inside. So it's going to be half y squared if we integrate y with respect to y. And then finally, we can just sub in the top limit and sub in the bottom limit. So if we sub in the top limit, we're going to have 10 times 10 minus a half times 10 squared. And then we need to subtract what we get when we sub in y equals 0, but that's just going to be equal to 0, so we don't need to worry about that. So we're going to have pi over 100 multiplied by 50, which simplifies to a half pi. Now, because we're solving a real life problem here, or a supposed real life problem, We should probably give a numerical value for that. So half pi is 1.57 to 3 sig fig. And we should also include units. Because the scale and the axes are centimetres, we know that this volume is going to be measured in centimetres cubed. And then part C is a really common type of question, as you probably already know from modelling questions. They like to ask what's the limitation in the model. The general answer that you can normally always give is that the exact shape of the pen isn't going to match the curve exactly. It's unlikely that it's going to be that quadratic shape exactly. So therefore, we're either going to underestimate or overestimate the volume required.